All right, let's talk about Amazon S3. If you're studying for your AWS Solutions Architect exam, you know S3 is a big deal. It's absolutely foundational. So let's dive right in and make sure you've got the core knowledge you're going to need. So let's kick things off with a number that you absolutely have to know, and it's a big one, 11 nines. That is S3's data durability guarantee. So what does that actually mean? Well, it means if you store, say, 10 million objects, you can expect to lose just one of them about every 10,000 years. Now, for the exam, remember this key distinction. This number is all about durability, keeping your data safe from being lost, not necessarily its immediate availability. Okay, so here's our game plan. We're going to start with the absolute fundamentals, the building blocks. Then we'll get into the key decisions an architect has to make, things like cost, security, and performance. And finally, we'll see how S3 is really at the heart of modern cloud-native applications. First up, let's lock down the absolute fundamentals. You really have to get these core concepts down before you can even think about tackling those complex scenario questions on the exam. The first thing to get your head around is that S3 is not like the file system on your computer with all its nested folders. Nope, it uses something called an object storage architecture. The simplest way to think about it is like a giant flat key value store. This model is what lets S3 scale to, well, trillions of objects without grinding to a halt like a normal file system would. Everything you're going to do in S3 really just boils down to these three core ideas. First, you have the bucket. This is your main container. And here's a critical point. Its name has to be globally unique across all of AWS. No two people can have a bucket with the same name. Then, inside that bucket, you store your objects. An object is just your data, an image, a video, a log file, whatever, plus some metadata about it. And finally, every object has a key. The key is just its unique name inside that bucket. You can think of it like the full path, something like images/puppy.jpg. And just to really hammer home what we mean by scale, get this. As of 2025, S3 stores over 500 trillion objects. Yeah, that's not a typo. 500 trillion. That's the kind of scale you're designing for as a solutions architect. Okay, this next part is where you really start thinking like an architect. It's all about balancing that critical trade-off between cost and performance. I mean, you definitely don't want to pay for super fast access to data that you only look at once a year, right? And that's exactly what S3 storage classes are for. This table lays it all out beautifully. You've got S3 Standard, which is your go-to for hot data that you're accessing all the time. But if you have no idea how often data will be accessed, intelligent tiering is a total game changer. It just automatically moves your data to the right tier for you, saving you money. And then for archiving, you have a whole spectrum, from Glacier Instant Retrieval for archives you need back in milliseconds, all the way down to Glacier Deep Archive, which is literally the cheapest cloud storage you can find, but retrieval takes a few hours. And the best part? You don't have to do any of this by hand. As an architect, you use S3 lifecycle policies to just automate it all. You can set up a simple rule that says, hey, after 30 days, move this data from standard down to a cheaper class. Then, after 90 days, archive it to Glacier. And after 7 years, just delete it. You set the policy once and S3 just takes care of it.
Okay, so we've got our data stored in a smart, cost-effective way. What's next? Well, we have to lock it down. And this isn't just a nice-to-have. For a lot of industries, it's a strict legal requirement. And for that, one of the most powerful tools in your arsenal is S3 Object Lock. It enforces what's called a worm model, write once, read many. Basically, once an object version is locked, it becomes immutable. It cannot be changed or deleted for its entire retention period. End of story. This is huge for compliance and fighting ransomware. Now, pay close attention here, because this is a classic exam topic. Object lock comes in two flavors. Governance mode is great for protecting against, accidental deletions, but people with special permissions can still bypass it if they have to. Compliance mode, though, that is the highest level of protection. Once an object is locked in compliance mode, no one, and I mean no one, not even the root account, can delete it until that retention period is over. All right, so our data is cheap to store, and it's super secure. Now let's make it fast. Because S3 isn't just some vast, cheap storage shed. It's an incredibly high-performance service, but only if you design your solution the right way. And S3 is an absolute beast when it comes to speed. It can handle, at a minimum, 5,500 read requests, like GET or HEAD requests, every single second. And that's per prefix in your bucket. A prefix is basically anything that looks like a folder path in your object's key. And on the flip side, for writing data, so puts, posts, or deletes, it can sustain at least 3,500 of those per second, again, per prefix. The big takeaway here is that S3's performance scales out horizontally. If you need more speed, you just spread your requests across more prefixes. It's that simple. So how do you actually get this kind of performance? Well, as an architect, you use a few key design patterns. For instance, you don't download a huge multi-terabyte file in one single stream. Instead, you use what are called byte range fetches to request many different chunks of the file all at the same time, in parallel. And if you're uploading files from, say, the other side of the world, you use S3 transfer acceleration. It routes your data over AWS's own optimized global network instead of the public internet, which can speed things up dramatically.
Okay, this is where it all comes together. The really crucial thing to understand is that S3 doesn't just sit there by itself. It's very often the central hub, the trigger, for all kinds of modern serverless architectures. Think about it. The old way was to have a server running 24/7, constantly asking, is there a new file yet? Is there a new file yet? Which is super inefficient. Now you can build event-driven systems. S3 can just send out a notification the instant a new object lands, triggering other services to react immediately. And this is the poster child for serverless architecture, a pattern you absolutely have to know cold for the exam. A user uploads an image to an S3 bucket. That upload event instantly triggers a Lambda function. The function then runs, maybe resizes the image into a thumbnail, and saves it back to another S3 bucket. The beautiful part? No servers to manage, and it scales pretty much infinitely. And this all leads to probably the biggest takeaway of all. The S3 API has become so powerful, so widely used, that it's now the de facto standard, the universal language for object storage, not just on AWS, but across the entire cloud industry. You'll see tons of other storage providers advertising that they have S3-compatible APIs. So when you put it all together, balancing cost with storage classes, locking down data with object lock, scaling performance with parallelization, building these powerful event-driven workflows, these aren't just exam topics. This is the blueprint. It's how you'll go beyond just passing the exam and start designing and building truly robust, scalable, and cost-effective solutions on AWS.